All right, this is our last chapter. Chapter 22 really ends this book on kind of a optimistic note, a note for looking forward. And so really the two main things that I want to touch base on out of this chapter are this idea of One Health, this global initiative, and then also I call it Microbes to the Rescue. I think it's like the second half of the chapter where they start talking about, okay, here's some of the environmental problems we have, and here's how microbes can step in. So we'll end on an optimistic note here. Though interestingly, when I look at this idea of One Health, right? So this is this idea that there's really an interaction between people, animals, and the environment. And you think, oh yeah, of course. Well, that makes sense, right? There's, you run into a moose when you're hiking, or you're really glad that there's clean water coming out of the mountains for us. But then also as part of this kind of overlap, part of this triad is the idea that microbes are shared between these environments, right? There's actually really neat studies talking about why people should garden, right? Having your hands in the soil, having that interaction with the microbes in the environment has actually shown to be really healthy, right? Things like that. So we know that there's this overlap, and One Health is trying to encourage us to really consider that, to think about it, and in ways where we could use that for its beneficial purposes, and then other ways where maybe we should consider that our actions might be negatively influencing this kind of overlap of these three areas. Okay, so, and this is fun, right? Health is actually an acronym for humans, environment, animals, right? Those are the three things we just saw, living together harmoniously. I feel like there must be a person somewhere that this is like all they do for a job is try to make acronyms. You don't have to memorize this one as long as you understand those three overlapping parts of the One Health. So, one of the things that we see through this One Health initiative as we've started to look at some of these interactions more closely, right, is that emerging infectious diseases are on the rise. And here we are, COVID-19 is one of the perfect examples of this. And so what we have to kind of reckon with is this idea that human activities are actually causing ecological disturbance and the movement of animals, right? So you can't just like move into an area and think that you have no impact. So a few things have played a big role in how these diseases jump to humans, right? So for one, the density, particularly of cities, right? But more people living closer together provides a great opportunity for microbes to spread. Now, I'm not saying cities are a bad idea. That's one of the most sustainable things we can do is keep our people kind of packed in the cities and leave some room for other organisms and the environment elsewhere. But it does allow for really the rapid spread of disease. We also see greater human contact with both wild animals and domestic animals. So, for example, we've already all talked about the fact that we think this coronavirus moved to humans out of bats, right? Or you're watching a documentary right now about Ebola, and they think that moved out of bats, right? And that it's maybe hunting some of these wild animals in this close contact. And then, of course, if you build a road way back into the forest and put your house there, right? We have more opportunities for those interactions. And so we'll see that with big logging roads in areas, etc. On the domestic animal side of things, if you think about something like swine flu, H1N1, where we had this recombination of different influenza viruses, right? There was an avian flu and a human flu that both infect the same pig. And then because in lots of parts of the world, people live in really close contact with their domestic animals, right? If you've been to a third world country and the house maybe is raised up and underneath it is where their animals are living, right? That close contact allows for things like that newly recombined flu to move into a human host. So it's just the way it is, right? Lots of people and we're having more contact with these animals. And then The third thing really to think about the way humans are kind of affecting this system is really the use of our resources, and particularly multiple uses, right? So your book, I think, rightly points out water, right? And in a lot of parts of the world, water is really hard to come by, and clean water might be impossible to come by, right? But people are using it for multiple things. So, for example, in some countries, there isn't great sanitation, and so waste is going into the same stream that someone downstream is pulling out to irrigate their crops or to wash their clothes or to drink. We'll see in the desert Southwest, for example, water being used multiple times for irrigation purposes, right? Places in the world where you're bathing in the same water that you're grabbing a bucket of for drinking water. So that sort of thing as well. So when we look at these, and this last example down here was just the way, particularly in the US, this like suburban sprawl, that we just like hack out a corner of this forest and plop a bunch of houses in their fescue lawns, definitely changes our interactions. We'll talk a little bit about Lyme disease, but this would be a really great example of where now suddenly these hundreds of homes, the people that live in them, their dogs, are in much closer contact with deer ticks, right? And they might pick up those ticks that pass on Lyme disease, right? So when we think about emerging infectious diseases, right, keep this kind of stuff in mind, right, that we're changing our interaction with the environment, we're changing our interactions with wildlife. And that's important too, because of these emerging infectious diseases, 75% are zoonotic, right? They're animal diseases that then can move into humans. And actually, one of the things I really like about this One Health initiative is they point out, those diseases can move back to animals as well. And we see that right now. Did any of you see it? It's like 15 million mink or something that they're going to slaughter in Denmark, I want to say. Did anyone see this? Because they're able to catch the coronavirus. It looks like the coronavirus actually mutated in these mink and we're able to pass it back to humans. And so we weren't worried about the mink, but we are concerned with it coming back to humans. And so they're going to slaughter them, right? But think about maybe a closely related species. We have an endangered species, the black-footed ferret, that lives more on like the eastern plains of Colorado. What if we give it coronavirus and it goes extinct, right? And so One Health would recognize that you can make animals sick. Same thing, I remember having a hamster growing up, and if I had a cold, right, if I had any kind of respiratory infection, I wasn't allowed to play with the hamster because there was the risk that I could make it sick. Okay, so what I wanted to do is talk about a couple different diseases in the context of this One Health initiative. I'm totally in the way here. And so this is one that I just find really fascinating. So rabies, right? So rabies is transmitted by a virus, or is caused by a virus, right? And this virus, if you looked at its host range, it can infect many different mammals, but it only infects their neurons, right? And so this is attacking the nervous system. So signs and symptoms, you're looking at things like fever, headache, weakness, discomfort, but this then progresses towards insomnia, right? Not being able to sleep, anxiety, confusion, partial paralysis. So you can start to see the impacts on the nervous system. Hypersalivation, difficulty swallowing, hydrophobia, which is the fear of water. So you should be drinking, right? You're having difficulty swallowing, you're not going to drink water. And this eventually leads to death. Like basically 100% of the times, if you contract rabies and it's not treated super early, you're going to die. So basically what we found is that until the late 1800s, when Louis Pasteur discovered that this was caused by the rabies virus, and actually that's kind of interesting. I don't even know if he knew what a virus was. He was able to develop a vaccine. And so what they did is they had an infected rabbit, right, a rabbit that had contracted rabies, and then they let the They kill it, they dissect the neurons out. They knew this was affecting their nervous system, dry those out for days to really weaken the virus, and then they were able to use that to vaccinate people against virus. So what we do now is we can actually give the vaccine right as soon, if it's given as soon as someone has been bitten, right, or potentially exposed, it is 100% effective, right? So if you get bit by a dog or a bat or some weird wild animal, you want to do your best to take that in with you because they can test it for rabies, right? If you don't have the animal and we're not sure, they are going to give you the vaccine for rabies because if they don't do it then, rabies is so lethal. And I said 100%. There was, as far as I know, in 2004, I have this written down, an American teen survived unvaccinated, right? So she didn't realize, I don't remember the whole story. She didn't realize she had been infected or didn't think it was that big a deal, whatever had bit her. And they actually had to put her in a medical induced coma. And I think this was for a couple weeks. And she was able to survive. Not ideal. So they're going to give you the vaccine. Now, what's fascinating, right, is that in places in the world where rabies is running rampant, you very well may want to vaccinate humans. But what we've chosen to do here in the US, because rabies is so rare, is to vaccinate dogs. So how cool, right? Like, so we're admitting there is some risk to vaccinating people against rabies. So here's how we're going to step in and stop transmission. So this is the One Health triad, right? It's saying, okay, our interactions with animals are really important in how this particular disease spreads. And so we'll vaccinate dogs, right? And that has dramatically decreased the number of human cases. In the US, it's like 2 human cases a year. Now, worldwide, it's much higher, and there's something like 50,000 fatalities a year. So, shoot, World Rabies Day was in September, and I missed it. So this map, you can kind of see here how, at least when this slide was put out, shoot, I don't have a year on this. This is probably like 5 years old now. They're showing where rabies was still running rampant, right? So South America, Africa, and Asia. And then this is kind of their plan, right? So they want to see less and less rabies by vaccinating people, vaccinating dogs, to the point where 2030, we could say 0 deaths worldwide. And so that's a pretty tall order, but really neat. So again, One Health says something about how we treat our domestic animals, and that can influence our health. And so that's pretty nice. And in fact, here in Steamboat, if you get bitten by a dog, I got bit a couple years ago, who has tags, right? Owners here are required to vaccinate a dog against rabies. And so I got bit and they did not have to vaccinate me because that dog had tags. I didn't catch the dog. I did not kill the dog. But we went ahead and made the assumption, right, that it had been vaccinated. And we felt pretty safe with that. Okay, another emerging infectious disease that I wanted to talk about because we've experienced this in our lifetime, right? So West Nile virus first arrived in the US. It came in at New York City in 1999. And we're still not sure whether it came in on an infected human, bird, a mosquito, like what happened, right? But the virus made it here. This is a virus that had been in Africa, hence West Nile. And it causes an encephalitis. So it causes inflammation in the central nervous system. And so it makes you sick and it can kill you. So we have, right, and it infects people and birds. They get sick or die. And here in the US, we've had, since this was introduced, thousands of fatalities in humans, and then also people who are just permanently neurologically impaired from this virus. So I thought this was a neat example of One Health because it was actually a vet at the Bronx Zoo who put the pieces together and realized that this new infection had entered the US. And so One Health makes this point too, is like there maybe should be more collaboration between vets and doctors, right? We think of, oh, they're just a vet, they're taking care of animals, but they run into the same kind of health problems that humans do. And this is a case where a veterinarian actually figured out something that was super important as far as public health, human health. So there you go, One Health, these interactions. I also thought this was kind of interesting. Yeah, these maps are a little bit outdated now, but it was kind of interesting because you could see it moving across the country, right? So now it's moved across the whole eastern seaboard. In 2002, it goes west in the Mississippi and just takes off. In 2003, it really picked up in Colorado. And then in 2004, we can see that it's made it all the way across the country. But what's interesting is, so like if you did these as a time lapse, it would look kind of like this wave moving west across the country from its point of import. But it's actually become much less problematic since its introduction. We have a lot fewer illnesses and fatalities due to West Nile virus. Okay, Lyme disease. This is a terrible picture to start with, right? A tick burrowing into someone. And then this is this bullseye rash. This is the characteristic sign of someone who's been infected by Lyme disease, though it doesn't always appear. We're not there yet. Sorry, gross picture. Okay, so basically what we've seen here is kind of that idea of suburban sprawl into New England forests. So one of the big things that happened in New England. And this is, again, the environment is so tightly intertwined here. So we started seeing, how do I say this? That New England was one of the few places, probably in the country, where forests were growing back faster than they were being destroyed. So what happened is early settlers had farmed these really marginal lands, right? They're just trying to eke out a living. But as farming has become more and more industrialized, it no longer made sense, right? So there are some hillsides that you would say plow with a team of horses, but that you wouldn't take a tractor on because it would roll, which is just as well. If it's that steep, it shouldn't be farmed. Erosion has been a big problem. And so anyway, these small farms have been abandoned and are returning to woodland, which could be a really good thing. But what happened in there is a series, like a whole overlapping mishmash of things, right? So deer populations explode. There's no predators, right? We've eliminated wolves. And then you can't really go hunting in suburbia, right? You need like a big state forest or a national forest or something for that hunting. So deer populations are on the rise. Mouse populations are increasing with that habitat change as well. And so what we saw this huge explosion of are deer ticks because they have lots of hosts. They live on deer, they live on the mice, they'll live on humans, their dogs, etc. And so these deer ticks carry a bacterial species called Borrelia burgdorferi. That's a good one, Borrelia burgdorferi, and that is the causative organism of Lyme disease. So it was first discovered near Lyme, Connecticut, in the children, and they were developing these arthritis-like symptoms, right? Not something you expect out of children. And so that's when we first realized this was a new emerging infectious disease here in the US. And so definitely that increase in the suburban woodland interface has been problematic. The lack of predators has been problematic. And even this increase in global temperatures, we see not just increased numbers of ticks, but an increased range of where they'll live. So that's something definitely to consider with climate change, right? If you looked at the progression of where we knew about Lyme disease, some of the spread is just natural, right? As that bacteria starts moving through the hosts. But some of it is showing up in places where normally, say, it would be too cold. And so it's moving up into the, New Hampshire, Vermont, Maine, Wisconsin, things like that. There's actually a picture in your book, and it looks like it's pretty bad, pretty common up in Wisconsin. So the next picture is the gross one, talking about HIV/AIDS. I won't stay on it long, but what I wanted to point out, again, HIV/AIDS was this emerging infectious disease, right? We first noticed it here in the US in the 80s. It'd probably been around in Africa for I don't think we know the exact date, but I've seen it's probably been around since the 50s and 60s. It just wasn't that prevalent. And now we're to the point, right, where there's 70 million infections worldwide, 35 million deaths per year. That's got to be 70 million new infections a year, 35 million deaths a year. There's two main strains that infect humans, right? HIV-1 and HIV-2. And so we think it actually jumped from the great apes. So the gorillas and things like that carry a disease called simian immunodeficiency virus, and it looks like it moved to humans at least 2 times. And so I have the terrible picture because we think how it moved to humans was actually through the bushmeat trade. So going into the forest, hunting gorillas, right? And they're closely enough related that some of the viruses that they carry could have moved into humans and then became this major, of course, pandemic in humans. Colonization changed this, right, where people groups were kind of marginalized and maybe pushed deeper into forests. Urbanization contributed to the spread, for sure. Okay, so not to end on like terrible diseases that seem like they're the blight of humanity, because really the point of that chapter is this, or of that section of the chapter, is this thought of being optimistic, right? We have the tools to say, wow, we know that we're causing these interactions, right? How can we address these things? And so stuff that we should probably study more and put more funding towards to prevent some of these outbreaks instead of just saying, man, how do we end up with coronavirus, right? This was predictable, and we could have done a lot of things very differently. Not saying that it wouldn't, have emerged, but yeah, so thinking about what we want those interactions to look like, how we can think more holistically about environment, environmental health, human health, and animal health. Okay, so microbes to the rescue. This is a fun note to end on, and we know a ton of this, so I'll go through here pretty quickly, right? But we know that bacteria, that viruses, fungus, protists, all of these microbes we've been talking about now for months, they're not the bad guys, right? We have great relationships, and I thought this was a really neat picture looking at the human microbiome and just pointing out all these different bacteria, and this is a small fraction of them, right, that we have great interactions with. A couple other places where microbes can be super beneficial, and so humans really need to think about harnessing them or mimicking them and coming up with ways to solve some of these major environmental problems. So this is one, for example, where we're looking at water treatment, right, and wastewater treatment. So I don't need to go into like gruesome detail here. Has anyone been to a wastewater treatment plant? Like sometimes they take students on tours of the wastewater treatment plant. I've been on a few of those, right? So realizing that one of the big problems we have is that wastewater contains lots of organic matter, right? So if you think about flushing a toilet, there's paper, there's poo, right? Organic matter. And what ends up happening is if that organic matter, say what we used to do, and some places still do, if we just dumped that into a river, right, or we pump that out into the ocean, bacteria find the organic matter and start decomposing it, right? They're decomposers, that's what they do. But the bacteria, as they're attempting to break down all that organic material, they use up the oxygen. And so we develop these dead zones. And so basically what we see happening is at the mouth of the Mississippi, we have this huge area and the size kind of fluctuates. Last I heard, it was like the size of the state of Pennsylvania, where the oxygen is dramatically lowered, right? So notice here, this red is like 0 to 0.5 milligrams per deciliter. And so what we end up happening is the bacteria use up the oxygen in the water to decompose this material. And then the fish and the crabs and the crayfish and the mussels have no oxygen. And so they die. So they call this a dead zone because it's basically devoid of oxygen, and therefore lots of organisms in there die. So you can even have these like fish kills where there'll be all the big one in the Gulf of Mexico, right, is if you think about the Mississippi, it's draining all these agricultural lands. And so all of these chemical fertilizers, nitrogen and stuff ends up in there. And so as it comes out the Mississippi into the Gulf of Mexico, suddenly there's all this nitrogen, all this fertilizer, and it feeds the algae. The algae take it in just like a plant would. And so you have this huge algal bloom, just algae gone crazy, right? Like, woohoo, so much food, I can photosynthesize, we're doing great. But then they die. And that's basically organic matter, little algae bodies sitting in the water. The bacteria come in to decompose it and suck all the oxygen out of the water. And then all the fish die and float to the surface, right? And so it's just this messed up situation that's taking place. And so thinking about how to lower those pollution levels, organic matter levels is important. So if you live in a rural area, some of you probably grew up with a septic tank, right? Basically just like a settling tank for any solid waste that's coming out of your house. And then you would have had what's typically called a leach field, where you have perforated pipes kind of running out in an area. And by removing most of the solids back here, just letting it sink and occasionally having someone come and pump it out, it actually does a really good job of decreasing the organic matter. And then as long as there's few enough people in an area, right, this is a reasonable way to handle human waste. You'll notice, some of you may have noticed down in Stagecoach, those developments, you actually can't have septic tanks. So when that area got approved, they put so many lots in, and they knew this at the time, that they weren't going to be able to have septic tanks. There wasn't enough room for leach fields to appropriately get rid of this waste. So what you'll see there is people have vaults. So instead of settling out the solid material, they have to have someone come pump and take away everything, right? So every time you wash dishes and water goes down the drain, that's going to have to get hauled away. Okay, so that's different than commercial plants, but they run off of a lot of the same ideas. Again, in here, what we're trying to do is basically settle out the solid waste. But then what they do in these water treatment plants is they say, okay, we know that bacteria are the decomposers. They want to feed off this, but they're going to use up all the oxygen. And so we can do that in the water treatment plant. So we actually allow bacteria to come in and do the breakdown of those materials, right? And in fact, in some places, like you can use, they're looking like they're using maybe sand and coal, that's interesting, as kind of a filter, but you can actually use sand as like surface area for biofilms and things to grow on. Somebody wrote a paper, I think, on that one too, right? And so we can use the microbes. They won't mind. They don't feel used. They just think we're feeding them. So you can do that. There's also been some really interesting research where people are making these constructed wetlands, right? And they're saying, hey, there was already a part of our environment, it was called a wetland, that was meant to filter wastes before they ran into, say, a river. And so that's basically what we're doing here. Again, a lot of times you have like a settling tank to get rid of most of the solids, but you would let water then move into a bed of plants, right? Things like cattails are great at grabbing nutrients, right, out of that water, and eventually having clean enough water that you could move that out for irrigation, or to go back to a river or something like that. And so there's some places in the US, I think Oberlin College has one, where they've set up these constructed wetlands, and that is how they actually handle the waste from their humans. I think at this college it's just one building that they've set this up for, but still kind of interesting. How can we mimic the environment? How can we know that plants and microbes have this relationship, right? And they're willing to use these wastes and this wastewater. So kind of some fascinating ways we could go there. As far as solid waste, and I will say any of those three that I just mentioned are way better than what we see happening in lots of places in the world, where we just pump domestic, like sewage out into the ocean, right? Where it goes away until it like comes back onto shore and you have to close the beach. I thought it was interesting. Your book talked about how we actually came up with an arrangement in Southern California where we actually pump Tijuana's waste to the San Diego wastewater treatment plant to get rid of it, because they were just flushing it into the ocean, right? It's a poor country, and so they didn't want to spend the money to get rid of the wastewater, but then it's washing up, of course, on California beaches, which isn't so wonderful, and so we're actually taking care of the problem. I thought that was an interesting example. Okay, solid waste, right? So 150 million pounds of waste a year here in the US. A lot of that, of course, metals, plastics, glass should be getting recycled, but we're not very good at that. But then we end up with a lot of material that in there that's biodegradable. And the Yampa Valley Sustainability Council actually did a survey a couple years ago, going through and looking at waste and how much of that was biodegradable. And so here's the problem, is when it gets buried in a landfill, when it gets buried, the only kind of decomposition that can take place is anaerobic decomposition. So you have these microbes that can work on it. It's not near as fast, and so these big holes in the ground are just filling up, and very little of that biodegradable material actually breaks down. That which does, those bacteria, the anaerobic bacteria, are actually producing methane gas, which is a potent greenhouse gas. So you have two options. Some landfills have gotten super creative, and they've actually found ways, like when they cap an area of the landfill, they actually stick pipes in to capture the methane, and they can actually create electricity and heat and things like that there at the landfill. But a lot of places don't do that. We don't do that. So then this picture here on the right is actually from, I want to say it's down at Silverthorne, a huge composting operation. So composting, basically you could use that same waste, right? It all has to be biodegradable. You don't want the plastic bags and stuff. But you get the correct ratios of carbons and nitrogens. And so typically composting, they talk about browns and greens. So they're using wood chips here to provide a lot of the browns. The greens would be all your kitchen scraps, things like that. And you want to keep the decomposition aerobic. So it's often getting turned, flipped over, and it's a really neat process where you start out with these like mesophilic bacteria, and as they're doing decomposition, they're producing heat, and this pile actually starts to heat up, start to steam, but it gets so hot that the mesophiles can't live anymore. And then we see thermophiles coming in and kind of taking over this process. And so you can put a thermometer in this pile, watch the temperature change, and the microbes that are living there would adjust as well. And then you have soil, right? And you could actually feed that back to your plants. A composting company just opened in Phippsburg. I think they're calling it, I want to say Feed the Seed or something like that, right? This idea that they're going to make soil. Or maybe it's a play on it was your food scraps. And then anyway, so yeah, we can have the nutrients, all that carbon, all that nitrogen go back into soil right here in Routt County. Okay, last thing I want to talk about where microbes really can come in and make a big difference for us is in this idea of bioremediation. So sometimes as humans we screw up, right? We spill a bunch of oil. There are microbes that will break that oil down. So in order to help this ecosystem recover, I mean, you could just wait the decades until, this washes away, dissolves, other things move in, or you can spray it with chemicals. They did this with the Horizon, what was that, Deep Well Horizon, the oil spill down in the Gulf. They used a bunch of chemicals to get the oil to settle to the bottom of the ocean. Which kind of means humans don't have to deal with it, but you're messing with the ecosystem at the bottom of the ocean. And then people have also worked on, okay, what are the microbes that can actually break down petroleum? Petroleum is just old, dead dinosaurs, right? And so there has to be something willing to decompose it. And so you can then spray those bacteria on the oil spill, get them kind of moving that nutrient cycling process forward. And there's some really cool examples. Paul Stamets is a mycologist. He studies fungus. He has some really neat ideas on using fungus for mushrooms, right, for bioremediation. So again, this whole idea that microbes don't have to be our enemies, and in fact, if we pay attention to what they do, what they like, and we're willing to give that to them, they really could be our allies in fixing some of these big environmental problems that we have and or we create. So, okay, that is it. That is the last lecture of 2020. So I will see you guys in lab.